Okay, let us look on example 13.4. It's a bit different. Now they want the percentage analysis. Example 13.4. Okay, they are saying 1 kilogram of a fuel oil to a formula or C16 and HH30 is burned with 30% excess air. Nah? Okay, they're saying find the mass of the combustion products and the percentage analysis by the mass of what of combustion products. Nah? So if they want the percentage analysis, nah, you're going to find the percentage analysis of this of exhaust of what of products. Nah? The percentage analysis. So you need what the carbon dioxide, you need water, you need oxygen, you also need the nitrogen, but we are going to do it in the same way. But for oxygen now it's gonna be a bit different. Né? You also have to include these two formulas that I've added on the board. Né? Whereby you have to calculate the oxygen content of what of air, and then how do you calculate the oxygen content of it? It's gonna be the actual mass. Which formula do you use to calculate the actual mass? Is this one? Né? Divided by 23 divided by multiply by 23 divided by 100. Né? And then if for you to get the excess oxygen, it's gonna be the oxygen content, the one that you get here minus the mass of oxygen. And you remember I showed you how to get the mass of the oxygen using this equation. Eh? So the only difference is gonna be when it comes to the oxygen. Eh? But we are going to do it in the same way that we're doing. Okay, so let us do it. They said 1 kilogram of fuel oil to the formula. I'm given the formula, which is what? C16H30. Né? Okay, the thing is burned with 30% excess air. Guys, if they talk about the excess air, it's X. Eh? Whenever you see the excess air, just name it X, which is 30%. You see where we use X. You see on your formula, this one it have X. Nah? Alright, okay. Okay, so they're saying find the mass of the combustion products and the percentage analysis. So we are going to find the masses first. Nah? After getting the mass, and then we'll find the percentages. Né? And how do we find the mass? We are still going to use the same formula, because I said whenever you're given this, you have to use that formula. Né? Okay, let us see. So it's gonna be what? C of 16, eh? H 30 plus open bracket 16 plus 30 divided by 4. O2 is equals to 16 CO2 plus 30 divided by 2H2O. Né? Okay, let's put the atomic mass. Carbon, we said it's 12. Né? Multiplied by 16 plus what? 1 by 30 is just 30. Né? Okay, and then plus, can you simplify this for me? 16 plus 30 divided by 4. It's giving you 23,5 né? Or 2, okay, is equals to sorry. Okay, and then it's 16 by 2, which is what? 32 né?
So you're not plugging in?
No, this is just a number and it's multiplied.
Oh, okay.
Same thing that we're doing on, so it's multiplying this. Né? Okay, is equals to, and then here is 16. Okay, open brackets, carbon, it said is what? Is 12 plus 32. Né? Okay, and then here you have what? 15. Né? You have 15. And then okay, hydrogen I have 2 plus 16. Eh? Alright, okay. And then the other thing that you must know, guys, do you see that here I have a comb?
Yes.
Of what's this? 23,5. Ne? So on this, guys, you must have what? You must have what? The whole number. Ne? So in order for me to have a whole number, I must not use the 23,5. I must make it what? The whole number. Ne? So whenever you see that you have a comma, you have to multiply your whole equation by 2. So it means I'm going to multiply this by 2, this part by 2, this part by 2, this part by 2. You understand it? The reason being because I must have what? I must have a whole number here. Ne? So whenever you have a comma, make sure you get a whole number. So for me to get a whole number here, I have to multiply everything by 2. Ne? Alright, okay. So to make it easy, let us just simplify this first and then we'll multiply by 2. Ne? Okay. Can you do this one for me? Yeah, you get what? Triple two. Okay, plus 752. This part
704.
704 plus this part 270. Ne? And then I said you have to multiply everything by 2. Yeah. 344 plus 1,500. 04. Okay. Yeah.
1408.
1408. Okay, plus this part 540. Okay, can we check now if it is balancing? Add this side and then tell me what you get this side.
Balance how much of balance?
This side
1948.
1948.
It's not balancing.
This other side
It's 2 4. It's not. Oh, I'm not. That's all. Yeah, 1938.
so it means it's balanced. Ne? You see with this comma it was definitely not going to be balanced, ne? Because you're going to have a comma this side and then this side it was BA or number. Ne? So I said whenever you have a comma, make sure you multiply everything by 2. Ne? Alright, okay, so from here what do? I divide with my 344. Okay. Just divide for me. 3 comma.
Number 2.
Okay, this one is 1 kg, ne?
Yeah.
Sorry. Plus
3,387.
3887. Okay, is equals to
3,171.
171 kg plus the last part 1,216 kgs. Ne? Alright, okay, and you remember what we're doing? I said from here you have to calculate what we call the mass of air. Of air required. But before I get that, I have to get my mass of what? Of the oxygen. Which one is our mass of oxygen? Is this one, eh? Alright, okay. So guys, this one, the mass of air required, eh? Sometimes they call it the theoretical mass, eh? They call it the theoretical mass. So whenever you see they say calculate the theoretical mass or the mass of air required, it's just the same, eh? Don't be confused. Theoretical mass and mass of air required is just the same, eh? This goes to 3,387 multiplied by. Can you multiply for me and see what you get? Fourteen comma 72. Just like that. 3 decimal places.
20,726.
26, no? Kgs. Alright, okay. So you remember on the previous one, I said whenever you calculate your mass of air required, ne? I was going to end here. But on this case, do you see that I'm given the excess air, ne? So you only use this formula of the actual mass of air bent by fuel again, whereby you are given the excess air. Ne? For example, in this case, I'm given the excess air. But if it was not given, I was going to end here. Ne? But now I have to calculate my actual mass because I'm given the excess air. Ne? Okay. Okay, so it says the mass of air required, which is 14,726 plus 100 plus 30. Okay, divide by 500. Okay, just crunch for me and see what you get. 19.
1,438.
1 and 1. Are you getting the same thing or 19?
There are 16,06.
It's 14. Let's see.
16.
14,72.
So it's
There are 16.
me, I'm always multiplying.
No, sorry, I'm the one who made a mistake. It's supposed to be multiplied, not plus.
Yeah, so it's 191
Yeah,
then.
yeah. Can you multiply and see what you get?
191.
1 and 1.
Mm.
Because I'm saying they get 19, 19,1. Let's
Mm.
check your
That's
calculator.
why I carry it's 14 commas.
14, it's 19. It's 14,726 multiplied by 100 plus 30, which is like 130 divided by 100. Tonika, you're getting what? 19,
14.
14. Okay. kgs. Huh?
Yes.
Okay, so now I'm done with my actual mass. Ne? So where do I go? I go to the products. Ne? And then remember I said it's very easy for you to get the product of what? Of the carbon dioxide, also of the water. You just check on the equation. But now if you go, because now on the products of this, you also have what? O2. Ne? That's why you introduce which formulas. This, so I have to calculate my oxygen content first. Ne?
Yes.
Okay. I don't know the body if it's going to be enough. And then it says the actual, it has the actual mass. Do you see that? What is my actual mass?
19,1.
19,14. Ne? Okay. Multiplied by 23 divided by 100. 4,403 kgs. Ne? And then for you to get the mass of the oxygen that you use here, you are going to use this excess oxygen. Ne? Okay.
Now we are now.
Yeah.
Now we are now.
Okay. And then it says the oxygen content, ne? Minus the mass of the what? Of the oxygen. What is the oxygen content? Is this one? Ne?
That's one.
4,403. Ne? Minus what was our mass of the? What was our mass of the? Okay. So unfortunately my video it cuts along the way. Ne? So I said whenever you are calculating what the mass of the nitrogen, now you are going to use the actual mass multiplied by 77 divided by 100. Ne? Because remember the previous one we're using the mass of the air required, but now I said you have to calculate the mass of what the actual mass, because you are given the excess air. Ne? And then this is how you get your mass of what? Of the nitrogen. Okay. And then after, to get the total mass, you are going to just add your mass, which is the one mass of the carbon dioxide, the water, the oxygen, and also nitrogen. Eh? And then you get your total mass. And for you to get the percentage analysis now, you're just going to use the total mass. When you go to the carbon dioxide, you say the mass of the carbon dioxide divided by the total mass multiplied by 100. Ne? When it goes to the H2O, the water is going to be the mass of what? Of H2O divided by the total mass multiplied by 100. On oxygen, the mass of the oxygen divided by the total mass multiplied by 100. Ne? And then also the nitrogen, the mass of the nitrogen divided by the total mass multiplied by 100. So this is how you get your percentage analysis. Ne?